Space is not an empty void, it is teeming with giant clouds of gas and dust. These clouds are called nebulae. Nebulae are the birthplaces of stars. Gravity is a powerful force, it pulls the gas and dust in a nebula together. As more and more material clumps together, the cloud gets denser and hotter. Eventually, the core of the cloud becomes so hot that nuclear fusion begins. Nuclear fusion is the process where hydrogen atoms combine to form helium. This releases a tremendous amount of energy. This energy makes the star shine brightly. Our own sun was born in a nebula billions of years ago. Once a star ignites, it enters a long, stable period called the main sequence. Our sun is currently in its main sequence. During this phase, a star fuses hydrogen into helium in its core. The outward pressure from fusion balances the inward pull of gravity. This balance is what keeps the star stable. The color and brightness of a star depend on its mass. Massive stars are hotter and brighter than smaller stars. They also have shorter lifespans. Smaller stars are cooler, dimmer, and live much longer. Eventually, a star will run out of hydrogen fuel in its core. When this happens, the star begins to change dramatically. It expands enormously and becomes a red giant. Red giants are much cooler than main sequence stars, but they are also much larger. If our sun became a red giant, it would engulf the Earth. During the red giant phase, the star fuses helium into heavier elements like carbon and oxygen. This process releases even more energy and causes the star to pulsate. The outer layers of the star can be ejected into space, forming beautiful planetary nebulae. The fate of a star depends on its mass. Massive stars end their lives in a spectacular explosion called a supernova. A supernova is one of the most energetic events in the universe. During a supernova, the star's core collapses and then explodes outward. This explosion can outshine an entire galaxy. Supernovae scatter heavy elements into space, seeding the universe with the building blocks of planets and life. Smaller stars like our sun will not explode as supernovae. Instead, they will shed their outer layers, leaving behind a hot, dense core called a white dwarf. White dwarfs are about the size of Earth, but they contain as much mass as the sun.